Hi everyone, welcome to Electronic Stucky. So in this video, we are going to discuss about diodes. So what is the definition of the diode? What are the type of diodes? In that we discuss one of the diode very deeply. Okay. So let's see what is a diode. So what is the mean by diode means? So diode is a two-terminal electronic component that allows current to flow in one direction. So which means we already discussed about the resistor, capacitor, inductor, all those things. So in that, what will happen? So whatever the passive components we have, so in that, sorry, one minute I will arrange it. So okay, in that component, so what would be considered resistor? The flow of current in both the directions. But coming to the diode, so here the electrical, it is one of the electronic components. So what will happen in that only one direction only the current is going to be flow. See, this is the symbol of the diode. So diode symbol is like, so this part is anode. So this is cathode. Okay. So now what will happen is, so in anode, we said it is a positive terminal. Cathode is called as a negative terminal. So this is the symbol of the diode. This is the definition of the diode. So what is the definition of the diode? So diode is a two-terminal electronic component that allows current to flow in only one direction. Okay. Next, coming to the key points of the diode is like has two terminals. What are the 2 points here? Anode and cathode are the 2 points here. Act like a one-way valve for electricity. What is meant by one-way valve? So one-way valve is nothing but the flow of current is only in one direction. That is also from anode to cathode. Okay. So I have to remember this point. The current flow is only one direction. That is also from anode to cathode. So that's why we call it as one way. So one direction only the current is going to be flow. So that's why we call it as one-way valve for electricity, means current. So made from semiconductor materials. How it is going to be made? So by using semiconductor materials like silicon, germanium, like that, according to the requirement, by using the semiconductor materials, we are going to design or make these diodes. Okay. So forward voltage drop for silicon means the diode, you are giving 0 volts means the diode is in inactive state. So when it is going to be start or when it is going to be active means, so for silicon, if it is made up with silicon, the forward voltage means after the 0.7 volts only the diode is going to be conduct the current. So diode is allow the flow of current. So germanium, it is like 0.3 volts like that. Okay. So coming to the next topic, types of diodes. So what are the types of diodes we have? So the types of diodes we all have PN Junction diode, Zener Diode, LED, Schottky, Photodiode, and Varactor Diode. Okay. I already written here all the things. So PN Junction diode, Zener Diode, LED, Schottky Diode, Photodiode, Varactor Diode. So for PN Junction diode, so it is one of the basic diodes. So what are the things which are going to use on your design? This was the major and basic one. You have to know the complete working of this PN Junction diode. So it is a very much important in our circuit designs. Okay. So PN Junction diode is one of the basic diode, sorry, allows current in one direction. So it allows the current flow in only one direction. So coming to the Zener diode, use it for voltage regulation in reverse bias. So the mainly Zener diode is used in the reverse bias condition. So in reverse bias condition, we have discussed the forward bias and reverse bias in upcoming slides. Then you understand about this reverse bias, what is reverse bias and what is forward bias. So one thing we can do, first we discuss about the forward bias and reverse bias, then we come into these types. Okay. So coming to the PN junction diode. So in PN junction diode, what is the definition of this PN junction diode? So a PN junction diode is formed. So how is this PN junction diode is going to be formed means, so when a p-type semiconductor is joined with the n-type semiconductor, so the material having p-type and the material having n-type. So when these two are going to combine, then this PN junction diode is going to be formed. So in between this PN, a junction will form. Here you can see there is a junction. So junction will form and it make it as a PN junction diode. So see here in P-type, what are the things? So in p-type, the majority charge carriers are holes. That means positive charge carriers are present in p-type, doped with boron. So I already discussed that doping concept in previous video. If anyone don't watch that, go through that thing. So here for getting the p-type, means p-type semiconductor. So intrinsic semiconductor. So intrinsic semiconductor means pure form of silicon. So pure form of semiconductor. So when it is going to be added with impurities, so we call it as impure. Nothing but extrinsic semiconductor. We are call it as extrinsic semiconductor. Okay. So here for getting p-type, for pure silicon we are going to dope with boron atom. Then it is going to be form it as a p-type semiconductor. So pure form of silicon is doped with penta, means trivalent impurities, that is boron. Okay. So majority carriers in the p-types are holes and minority charge carriers in the p-type are electrons. Okay. Coming to the n-type, so it has negative charge carriers. So it contains negative charge carriers, means electrons. So in n-type, the majority carriers are the electrons and the minority carriers are the holes. How we are going to get this n-type? So pure form plus pentavalent impurities, means phosphorus. Okay. Phosphorus we are going to be doped, then we get n-type semiconductor. So when p-type and n-type are joined, see here when p-type material and n-type material are joined, a depletion layer forms at the junction. So what are the things? So in between this there is a junction. So when there is going to be combined, there is a depletion region is going to be formed in between these two. So there is a p-type and n-type. So there is a depletion layer is going to be formed in between these two materials. Okay. So coming to the depletion layer and potential barrier. So we discuss about the depletion region. What is the depletion region? Depletion region or depletion region, what depletion layer, both are same. Okay. So in this thing, what will happen means, so what are the things in the p-type and what are the means things is nothing but the charge carriers. What are the charge carriers which is in the p-type and the charge carriers which are in the n-type are going to try to combine both. So then they form a layer called depletion layer. So where it is going to be formed? So in the junction, where is the in between the p-type and n-type junction, there is a junction which can be divided p-type and n-type material. So in that junction, the depletion layer is going to be formed. So see what is the depletion layer. Here the definition of the depletion layer written forms at the PN junction boundary. So when there is a PN, there is a P boundary, there is an N boundary. So in the boundary, the depletion layer is going to be formed. Okay. So coming to the free form N-type fill holes in the P-type creates a region with no free charge carriers. So what will happen? So there is a electrons. Majority carriers are electrons we observe here in N-type. So all are filled with electrons. Okay, not only this, the full N-type material is filled with electrons. In between there is some holes. Minority carriers will have holes. So here all of with positive charge. So all are having positive charge here in the p-type. So some electrons, some minority electrons will present inside this holes. Okay. So now what will happen means, so these electrons are, what are the positive charge? Electrons are going to be moved. So what are the holes, means what are the electrons which are present is moved, sorry, what are the holes present will be attracted to the this negative charge and try to move this side, n-type material. So what are the electrons which are present in the n-type? They are try to move towards the p-type because opposite charges are going to be attracted. So that's why they are try to move from opposite direction. Then they try to form a depletion layer. So all the electrons are going to towards the positive and p-type material, and all the holes are trying to move towards the n-type material. So then what will happen? A depletion layer is going to be formed in between these two. So that's the same. Free electrons from n-type fill holes in the p-type. So what are the holes which are going to move freely towards the p-type, which having positive charge of the p-type. So it creates the region with no free charge. So then what will happen? So they fill this like this. So all the holes are try to move here. So in what will happen in the boundary of n type, all will having positive charge. In the boundary of p type, all will contain negative charge. So then what will happen? They don't allow to get some more electrons to attract, because there is also a negative charge. There is also negative charge. They don't want to attract. So that's why what will happen? There is no flow of current further. So there is like a boundary. There is a wall can be created between this p type and n type. So this layer is this region or this layer we call it as a depletion layer. Okay, we call it as a depletion layer. We call it as depletion. So next what thing? Potential barrier. So coming to the potential barrier. So an electric field builds up in the depletion layer. So in the depletion layer there is a ions. So here the negative ions is going to move here and then present there and then recombine. There will be, so there will be charge carriers here. We observe. So there is, when there is a charge carriers, we know that there is an electric field. There is a charge, definitely there will be electric field in that region. So it build up in the depletion layer. These electric field opposes. So wait 1 minute, I will charge the thing. So an electric field builds in. So an electric field builds in. 1 minute, I will try to charge my laptop. It is going to be down. So I will explain while charging the thing. What till now we discuss. So till now what you are going to discuss? So till now we discuss about what is the p-type material, how you are going to get that p-type material, and how you are going to get the n-type material. All the things we discussed now. So now what will happen? For getting the PN junction diode, we are going to combine the p-type material and n-type material. So what will happen when you combine the p-type and material and n-type material means, so there will be a junction in between the p-type and n-type. So at that junction, the depletion layer is going to be formed. Okay. So at the depletion region, what will happen? So there will be a boundary. So in boundary, there is a depletion layer. When there is a charge, so there must be a electrical field will be there. Okay. So if there is electric field, what will happen? This electric field opposes further flow of charge. So these electric field, what is present in this depletion layer, so there further flow, it can oppose the further flow of charge. So there it can be no further flow of charge which can be present in this depletion layer. So for silicon, potential barrier equal to 0.7 volts. So means until 0.7 volts, this barrier doesn't allow any flow of current. And after the 0.7 voltage is going to applied at the input, then only these barrier, what is the field which have, is try to move the electrons through it. Okay. For germanium, potential barrier is equal to 0.3 volts. Okay. So coming to this PN junction diode, there is a two types of bias. So means in PN junction diode, so I have observed two. So one is forward bias and then one is reverse bias. So in forward bias, what will happen? So you know that there is a PN junction diode. See, it seems like this. So the p-type material is connected to positive. So there is a positive terminal of the battery, and n-type is connected to the negative terminal of the battery. So what will happen? So it will be connected like this. Then we said that it is a forward bias. So when the p-type material is connected to positive terminal and n-type material is connected to negative terminal, we call it as a forward bias. So now what will happen? So external voltage pushes the holes towards the junction. So here is also a positive voltage, here is also positive voltage. What will happen? So this positive voltage push this means opposes these holes which are present in the p-type. So these are trying to move towards the n-type. So whatever the negative charge, it can oppose the electrons in the n-type. So the electrons which are trying to move towards the p-type. So then there will be a opposite direction, the holes and electrons are trying to move. Then there is a recombination occur and the flow of charge is going to be increase in the forward bias. So electron pushed towards the N side, towards the junction from N side. So what are the electrons which are present in the N side is going to push towards the junction. So where is the junction? In between these two, there is a junction. So depletion layer becomes very thin or disappears. So then what will happen? There is a more voltage is try to push towards the junction. So the depletion layer which is present in between the p type and n type is going to be reduced. It will disappear. So it may be reduced or disappears. Then what will happen if the depletion layer is reduced? The flow of current will be more between the p type and n type. So current flows freely through the diode. So that flow of current is going to be very easy to move through the diode. So coming to the condition, positive terminal of the battery connected to the p type. So I already discussed what is the condition here. The positive terminal is connected to the p type, and so what it represents means the battery positive. So here a positive is connected to this p type and negative is connected to n type. The representation means it's like that. So negative terminal connected to the n type. So applied voltage must be exceed 0.7 volts. Why you are going to discuss? So we already discussed that the potential barrier voltage of the silicon is 0.7 volts, which means when you are going to apply that 0.7 volts more than this 0.7 volts, then only the diode is going to be conduct. So that's why we are going to apply the 0.7 volts. Exceed means 0.7 higher than 0.7 volts. Okay. So coming to the application, rectifiers, where these diodes are going to be used in the forward bias. So in forward bias for rectifiers, rectifier means the AC, what is the alternating current is converted to DC current. So what is alternating current, what is DC current, we discuss further. Okay, so it is used for AC to DC converters and LED lightning circuits. So what are the things which are going to display our LED? I mean, for light purpose, we are going to use this PN Junction diode. So signal detection in radios. So in radios, we are going to tune the signals. So for the signal detection, we are going to use this PN Junction. So logic gates in the digital electronics. So all the things which are going to be the applications of PN Junction in forward bias case. Okay, so in reverse bias, the application will be different. So don't confuse in both. Okay. So coming to the reverse bias. So what will happen in reverse bias? So see the condition. So negative terminal of the battery connected to the p type. So see here is the p type. So p type is connected to the negative terminal. So positive terminal is connected to the n type. So the positive terminal is connected to the n type. So in diagrammatic, if you draw like this, so negative terminal is connected to the p type and positive terminal is connected to the n type. Okay. What is the working here? So holes in the p type are pulled away from the junction. So if the negative, there is a positive charge. Okay. So what are the holes pulled towards away from the junction? So if there is a negative charge, it will be holes, means positively charged. So then what will happen? The holes are trying to move towards the battery, not towards the junction. So away from the junction is nothing but like this, in this direction. The holes which are trying to move away from the junction. So electrons in the n type are pulled away from the junction. So here also a positive charge. The negative charge are trying to attract towards the positive charge. So the electrons also try towards move away from the junction. So depletion layer becomes wider and thicker. So then what will happen? Till now the layer is like this. So whenever they are trying to move towards the away from the junction, so then what will happen? The depletion layer is going to be increase in reverse bias. So practically no current flows. In real time cases, there is no flow of current. We already discussed the definition of diode. What will the definition of the diode? So the flow of the flow of current is only one direction. So in practically speaking, there is no flow current. In theoretical manner, we said that some leakage current will be there. Some leakages, small, which is negligible current is going to be present in the reverse bias case. We said that. So application coming to the voltage clamping circuits, Zener Diode voltage regulations means in Zener Diode we are using the reverse bias condition then only. So for that regulation and suggest spike protection circuits, Varactor diodes in oscillators. So like this, these are the applications of the PN diode in reverse bias. So coming to the forward bias and reverse bias. So battery connection in forward bias, what will happen? So positive terminal to anode and negative terminal to cathode. Coming to the reverse bias, anode is connected to negative, cathode is connected to positive. Depletion layer, what will happen in a forward bias? The depletion layer is going to be decreased, means becomes thin and disappears. So in reverse bias, what will happen? It will be wider and more thicker. So the current flow in the forward bias is more. and coming to the reverse bias, there is no current flow. In the resistance, so you know that the current is inversely proportional to the resistance. Okay. So if the current increases means the resistance is very low. Here the resistance is very high. Voltage required for the forward bias is 0.7 volts. Greater than 0.7 volts means below the 0.7 it is not going to be conduct the current. So how to give the voltage greater than 0.7 volts. So there is no minimum current limit. Means whatever the thing we are going to apply, there is no flow of current, there is no use. So diode state on means it will be conducting. So in reverse bias, the diode state is like off. So it is not conducting any current. So now we discuss the types of diodes. So in Zener diode, what will happen? Used for voltage regulation, reverse bias. The Zener diode is mostly preferable in reverse bias case. So while you are going to use this means for voltage regulation. Voltage regulation means if the voltage is going to be increased, the current flow is be constant. So if the voltage we are going to increase, means sometimes the voltage fluctuations will be there, it is going to be increased. Then we are going to regulate, means we are going to control that in the constant way. So for that case, we are using these Zener diodes. Okay. So coming to the LED. So LED in full form is like light emitting diode. So it can be emits light, means it can be take electrical energy and converted into the light energy. So when it is going to be done means it can be worked in forward bias. So coming to the shortcut diode, for switching low voltage drop. So in Schottky diode, what will happen? Here in PN junction diode, we combine P-type and N-type material. So in Schottky diode, this P-type material is replaced with metal. Some aluminum or any type of material is going to be replaced. So one type material and another type is semiconductor. So that's why you call it as a metal semiconductor junction diode. So another name of the Schottky diode is, so what is the name of this? Is like metal semiconductor junction diode. So you also call it as metal semiconductor junction diode. So what will happen? Then there is only electrons are the majority charge carriers. There is no holes. So the mobility of the electrons are more than holes. So the flow of electrons towards the metal. So the conductivity will be more. So low voltage drop is nothing but in silicon we are required 0.7 volts to start the diode, to conducting the diode. But here in Schottky diode, we are going to use only 0.3 volts. By giving 0.3 volts only, the diode is going to be start working, start conducting. So what is the use means in mobile charges. Now we are going to use mobile charges now. So for fast charging, for charge your mobile very quickly, use this technology, Schottky diode. Okay, fast switching is there. So low voltage drop, for small amount of voltage only it is going to be start working. So these are the advantages of Schottky diode. Okay. So coming to the photodiode, so it is the reverse of LED. So converts light into the electrical energy. Consider light energy as a input and convert that into the electrical current. Okay. So coming to the Varactor diode, variable capacitance used in tuning circuits. In Varactor diode, what will happen means, see in reverse bias, we are going to, the depletion layer is going to be more, na? So we are using the variable capacitor we are going to use. So the symbol is like this. So there is a capacitance, it can be present in the reverse bias case. So like that we are going to tune the circuit by using this capacitance. So these are the some of the different types of diode. So till now what we are discussed in this video. So first thing we discuss about the definition of the diode. So what is the definition of the diode? In simply we say that a diode allows current to flow in only one direction. It has two terminals. What are the two terminals? It have anode and cathode. So anode is nothing but positive, cathode is nothing but anode is nothing but positive, cathode is nothing but negative. So third part is PN junction diode. So in PN junction diode, so we already discussed about different types of diodes also we discussed. Types of diodes also we discussed. So in PN junction diode, P-type semiconductor joined with N-type semiconductor. So in the P-type, it is a P-type material and it is N-type material. It is going to be combined, the junction will be formed. So what will happen now? So the depletion layer is going to be formed in between this P-type and N-type material. So depletion layer forms at the junction with no free carriers. Means there is no charge carriers. Means in the depletion layer they are both means what are the things. So if it is a P-type and N-type, so the electrons are trying to move towards the P-type. So negative ions is present here and the P-type the positive charge is try to move towards the n type and form the depletion layer. By this depletion layer, there is no free carriers present in this depletion layer, so there is no further flow. So next what we discuss, potential barrier. So what are the electric field which is present in this? Which is the electric field which is present in this depletion layer? We said it as a potential barrier, potential voltage. So prevents the current without voltage. Means for minimum voltage it is not conducting any current. It requires minimum 0.7 volts for silicon and 0.3 volts for germanium. Next, forward bias. In diodes, what will happen in forward bias case and reverse bias case? In forward bias case, diode is going to be conduct current and the depletion layer is going to be reduced. In reverse bias, the diode is going to be off. Means nothing but there is no flow of current and the depletion layer is going to be widened. So this is about the diode concept. So what are the diodes? What are the types of diodes? What will happen in forward case and reverse case? In that, what is the depletion layer and potential barrier? So all the things we discuss in this video till now. If you have any doubts, you can comment for it. There is a types of diodes also. If you want any type of diode explanation also, you can comment for it. So thanks for watching and thanks for supporting me, and then bye.